Hi there, this is Liang Hai, an independent researcher working on Unicode and open type matters especially for complex scripts. So this ongoing project is sponsored by TypoDeck. I would assume you by now already know what Indic refers to here. Basically, Indic or Brahmic scripts are descendants of the Brahmi script scattered around in South and Southeast Asia, used by more than 1 billion people. And for some reason, these very scripts are some of the most complicated cases for text encoding and shaping, and they're so unresolved in a technical sense. So this open knowledge based project is currently called Indic Text Shaping for Type Designers. Well, why type designers? Many think fonts are just for making text pretty. It is quite true for Latin, but there are also so many scripts out there still not having this luxury of thinking about getting pretty. And many newly encoded scripts don't even get a single usable font for years after they're encoded and standardized because they're encoded in such an abstract way that no one really knows how to build a workable font for them. So basically, no one really knows how to reliably rebuild the graphical structure, the visual images out from the encoded Unicode characters. So we have almost too many Latin typefaces and foundries already, while everyone still struggles to make even a single Indic font work. It's not right. It's not even a healthy market to us, this very little group of experts who more or less know how to build these fonts already. And this is why we're doing this. We're trying to open up our knowledge and share it with everyone, and also attract community participation, and to hopefully eventually reach some agreement, and we can even contribute back to some lower level standards like the Unicode standard when it makes sense for some of the content. And this project, as you can see on the slide, it consists of fundamentally a analytical framework, which is pretty much what this talk will be about, a tip of it, a tip of the framework. And then production tutorials, which we want them to be very readable and actionable for anyone who is a type designer professionally or just native user just wanting to make a font for this person's own script. And we'd like to provide first-party reference font sources, source files, source glyphs for reference, and source shaping rules, whatever, and a glyph-based script behavior database, a reference glyph sets, and what each glyph's identity is. And we'd like to provide configurable tooling so the high flexibility of Indic shaping can be addressed in a flexible way. And then, of course, community participation and the standardization. And so the potential value of this project is actually far more than just type design. It benefits many text processes that need to know a Unicode string's appearance when it's in some Indic scripts. But we aim at type designers for now because it's good to have very concrete, clearly understood readership, and also they are also naturally typical users, consumers of this kind of knowledge. And this talk, besides trying to introduce the technical background of the project, this talk also tries to change many people's badly misunderstanding mindset about how Indic text encoding and shaping is about. So first we can talk about some architectural context. So what are shaping, encoding, digital text, whatever, What are them? What are they? So look at your slide here. We have a loop, a cycle. I call it a life cycle of text, in particular a life cycle of digital text that is encoded. And so this cycle happens everywhere. It loops even when you're just typing a keystroke. You get to confirm the very typing result from the rendered visual feedback, which is reproduced from the digital text. And the digital text is produced by your keyboard layout, which is the input on the right-hand side. With the input, you decide how to input this based on the analog text in your mind or the text you see somewhere and you want to input it. So you can see how this life cycle works in a clockwise way. And it's so important. And it's been a very bad habit for many experts even in this industry itself, that many only think about their responsibility being just one portion, one link in this life cycle. Sometimes it gives them excuses to escape from being responsible for what their work means or how their work influences other stages in this life cycle. And so the vertical axis of this life cycle is about being most tangible, physical on the top, or being abstract and very digital on the bottom. And imagine it's a deep sea, and the surface kind of very messy here in our status quo, how we input text and how we display them in terms of how we deal with these complex scripts. And users often have to dive so deep into the bottom of the sea to manipulate the digital text directly. And why is that necessary? Because the whole point is, the whole point is just to reproduce the graphical form of the text. That's quite often what users ask for. And but they are forced to understand this whole life cycle and to manipulate the digital text directly and to going through the complex input and complex display processes just to get their analog text kind of reproduced elsewhere. You can already see, ideally, we should be able to hide the low-level complexity from user, and the user should be able only just to enjoy whatever that is exposed to them above the surface. So technically, each stage of the life cycle, mostly all of them involve two major families of technologies: Unicode technologies and OpenType ones. The Unicode standard in principle is responsible for the 12 o'clock to the 6 o'clock clockwise half cycle. That is how each analog text are represented in Unicode characters. But since it's a full cycle in nature, the other direction from 6 o'clock back to 12 o'clock is naturally coupled to the Unicode's half. Especially when how to encode a complex script's text is not a trivial, straightforward process. Then basically what Unicode standard's responsibility is to define how the digitalized text on the bottom of the cycle actually expects itself to be shaped by font technologies, so they can be reliably translated back to images of text. And when this kind of shaping expectation of Unicode is not standardized formally and clearly, that's the situation we're in now. And the open type technologies we have now, they are not really helping much because we all know open type layout, OTL, but it's only OTL as part of the open type specification. It's just a very low level technical framework on itself. It doesn't really specify how for each complex script, how each script should be shaped and how the shaping operations are supposed to be reliably executed. Microsoft does have several separate script development specifications, as how they are called, but those specifications are very incomplete, and honestly, they are full of mistakes, which is the main gap our project here is trying to fill. So let's take a simple script, Latin. You see the encoding process on the right side is largely just looking up a very straightforward table of character identities for each letter, however you understand it as a native user or a common user. Mostly you can find something in the Unicode standard in a character set that looks like the thing you want. And you just use the define code point and put up a character sequence on the bottom. And then for font, the character to glyph mapping process, the CMap thing, just maps all the characters back to images, and you get what you want. Of course, even simple scripts like Latin, they are not always that straightforward. Many of you already know the canonical equivalence problem and the decomposition, composition, mark positioning. But that's nothing compared to what complex scripts have to deal with. Complex scripts, there are scripts that are not directly encoded and shaped. So it takes so much effort to encode and shape them consistently. Even to start from encoding, on the right side, you see the so-called graphical segmentation is more or less what simple script, non-complex scripts have to deal with. And then everything else, all the akshara or the orthographical syllable-based phonetic segmentation and serialization. And they're very secondary, but they're highly necessary for executing a successful index script encoding, and how those, what I call double acting vowel killer or virama, or I'd like to call it these days a zero nucleus mark, and how zwitch and zwinge, they have to be utilized to override the shaping, because the automatic contextual shaping is not going to be able to cover all the cases. And then eventually you get a sequence, but that's only where the horrible story starts, because in order to get back to the visual forms you initially wanted to encode, you need to go through so many bizarre operations and treatments to get your encode code points back to the glyphs you really want there in your text. Those reordering, the vowel signs on the left side and conjoining contextual variation, productivity of those conjoining signs, and the prioritization of all of those operations, and how you order them, which ones are prioritized, which ones are shadows by others, and all of those special cases you need to handle, and you need to provide reasonable fallback for edge cases, and you still need to deal with local specific variation. Being so complex is not a coincidence. It's naturally hard to reconstruct all of these target glyphs from character sequence, because the character sequence itself contains overly abstracted information, because the encoding model, the ISKI inspired Indic encoding models, they were designed to record phonetic information for supposedly easier text processing, like sorting and text analysis. But they somehow missed a major point, that you need to at least get the text look right. So this is where we are now. Even the text itself, even to get the text look right, is such a major task. Even the basic graphical reproduction isn't done correctly. Not to mention the OpenType layout technology, its own restrictions, arbitrary restrictions, as well all of those buggy and incompatible shaping engines everywhere. Now you're losing me, you say, with so many concepts and terms. Exactly. We had so many steps and manipulations we need to deal with. Why does it have to be this hard? And so when we have such a complicated problem, what do? We introduce an abstraction layer, of course. So today's mess of Indic shaping is largely a result of early days oversimplification based on early days immature assumptions of how systematic, how predictable this kind of abstract back to graphical shaping could be. Now we know much more about the complexity, about all the edge cases, special cases that don't really fit into some naive, immature understanding. And now we understand early days bad decisions much better now. So it's time we improve the situation by properly recognizing and encapsulating the complexity under a well-designed abstraction layer to protect users from having to deal with the low-level mess. So where do we create that abstraction layer across these two major areas of complexity, meaning shaping and encoding? Let's remember our goal. Let's try to focus on the purpose, which is producing reliable fonts. So we shouldn't be over analyzing the situation, or say we shouldn't force type designers to over analyzing and detour for irrelevant complexity, which is how exactly each glyph is encoded in the first place and then is shaped. Then we need to divide shaping and encoding processes into some user-oriented, more straightforward parts, and the lower level already messed up, and but something we can hide from users. So an apparent way to do this is to reuse and align with the well-understood user-oriented APIs of these simple scripts like Latin, Cyrillic, and to make sure whatever we expose to users are more or less similar to the simple text, because those texts, they suffer the least, and they are more or less in a reasonable shape in terms of how they are encoded and shaped. So we start from text as images on the top again. We go to encoding. We stop right at graphical analysis. Anything after that is very arbitrary and model specific. And then we go ahead to text representation, and then we go to shaping. We deal with orthographical and critical shaping first to make sure the result is reliable and more or less stable. And then we leave the rest of shaping to type designers, font producers, to users those the typographical and more dynamic aspects of it. So in this way, the industry can own the lower level complexity and critical issues, and it can provide reliable solutions. And font producers, type designers can focus on what they're good at to produce beautiful, dynamic, lively fonts for users. And for newly encoded scripts, people should be able to quickly create fonts as long as they have glyphs for them. And you see, by connecting two distantly separated points on the cycle, we can create a wormhole that significantly shortens the trip needed by users who don't really want to touch the lower level complexity. We need to stabilize the wormhole with something though. And I use graphical segmentation, a concept I mentioned quickly earlier, which is pretty much the shared minimal required analysis for every script to be encoded. Basically, the complex scripts, they somehow received so much extra, and the industry couldn't deal with the extra very well. With graphical segmentation there holding up the wormhole, we are able now to create a figure eight, a stabilized figure eight, where its neck is graphical segmentation. It connects early encoding to late shaping, and anything above it is exposed to end users, and anything below it is what makes complex scripts, and it is the industry's responsibility to figure out reusable solutions. Being a higher level abstraction compared to Unicode characters on the bottom, graphical segmentation certainly still needs to be relatively stable and reusable, but it's not meant to be absolutely stable, like how Unicode standard is. Unicode standard has its own stability guarantee. Many aspects of it, once it's in, can never change it. For complicated issues, there isn't an internally best solution. That's why stability and extremely high exchangeability is not a bless. It's not always the bless. It's the responsibility of fundamental technologies like Unicode, but it's not always the best solution for higher level abstractions like the graphical segmentation wormhole we're talking about here. Because that kind of stability and exchangeability also means a huge lack of flexibility, because we would be forever stuck in some historical problematic solution when we didn't know better. So look at an example. Here is the same Devanagari string, a Devanagari line of text earlier. And people are used to this now. These days, whenever someone deals with digital text, we assume the analysis needs to be started from the Unicode string. And people both hate it, but they think it's very necessary to start with laying out this kind of Unicode string with all of those dotted circles flying around and those arbitrary technical viramas only there to conjoin letters. And people tried so hard to make sense of how these low-level encoded characters are composed again back into the shapes meant to be encoded in the first place. This shouldn't be necessary. Shaping transformation shouldn't be such a general burden to everyone. And why should Unicode's low-level representation matter to users? How Unicode encodes text is a result of a lot of historical reasons and the need the Unicode standard itself needing to serve all the text processes, not only display. So a generalized solution like the Unicode standard is almost never the solution just for you. And you need to create your own abstraction layer to serve your own needs and concerns. Even the very idea of combining these basic letters, like the letters you see in alphabet, and say this plus that equals to another conjunct, even this kind of idea is irrelevant to how typography and how end users should understand how texts are encoded. And this kind of combination thing is also naturally incomplete because orthographical analysis basically is never complete. It's always just an incomplete idealistic abstraction of the very fuzzy and naturally messy writing systems we created naturally as a civilization. So instead of that thing on the bottom of the slide, we should do graphical segmentation like this. Just break your glyphs apart and make your minimal consideration to figure out a way that makes sense to break them apart so the upper loop of the figure 8 can be served well. Isn't it just movable type and legacy digital fonts like those hacked ASCII fonts? Exactly. So the point is, don't be afraid to look back into older, seemingly immature or just legacy technologies, because things actually worked fine. At least fonts were reliable. Of course, Unicode brought in this whole level of possibility of being able to exchange text. But if you were just someone trying to type something on a single machine, those legacy fonts still worked. But we can't assume we're simply better off with our shiny new way of doing text because some aspects have improved. We need to reflect deeply how come it's got worse in some other aspects. Because movable type and non-Unicode fonts only try to resolve one thing, graphical reproduction. They didn't try so hard to address collation sorting and phonetic reconstruction. They just tried to get the shapes right, which worked. And many assume today's abstract analysis, like the ISKI-inspired so-called phonetic Indic model, which isn't really so phonetic fundamentally, and many assume, and also like the Arabic cursive joining model, many assume this kind of analysis models are good and don't even think about more straightforward analysis anymore. Those so-called legacy glyphic analysis. Many are almost allergic to a glyphic analysis when we discussed about this kind of potential. But for this project, we're not even doing encoding. And this so far looks very much like those legacy fonts, but we don't really stop there. Because this abstraction layer, if built right, provides so many benefits. So on the right-hand side for encoding, when you stop at the graphical segmentation, it's where the maximal textual abstraction you have when you're trying to encode the text. The further you go, you start stepping into the realm of basically creating information from external knowledge instead of the text itself. And then where you stop, the graphical segmentation provides a very reliable reference point for encoding of any scripts. Many don't really know how patchy the Unicode standard is about Indic script encoding. Graphical segmentation actually helps so much reconcile existing coding models, even for Devanagari, Tamil. For each of them, there are so many internal inconsistencies that we need to reinterpret and figure out a way to consistently, coherently explain them and formalize them and standardize them so we can provide reliable encoding guidelines and shaping expectation for fonts to deal with. Also, with graphical segmentation being a reliable reference point, we get to guide designs of new encoding models. Because this reference point is guaranteed to be textual and orthographically correct. Many starting points of encoding models actually lead to very non-textual results, like confusability only because we try to encode things very phonetically because people understand text phonetically. And we try to create contrast from thin air, saying this and that thing, they look exactly the same, but they are different things and encoded as different things. And also when we overly abstract text and we try to rely on those incomplete abstraction, incomplete contextual rules to shape encoded text back together, and we inevitably need to override the encoded text because the contextual shaping rules, they're never complete. That's why we need to build upon a concrete foundation like graphical segmentation and start from there, instead of starting with unreliable theories and then patch them. And for the left-hand side, for shaping, the graphical segmentation provides a relatively stable target, which is optimizable. So the whole industry can focus on a relatively well-defined abstraction layer and just pour our efforts on it to optimize for user experience instead of letting all the type foundries and users to redo the whole shaping process from text to glyphs over and over again, creating so many incompatible and quite often incorrect shaping results. And when you're an end user like a type designer, graphical segmentation is just generally the foundation you need to touch. You build from it. It's comprehensible and it's got reusable tooling and the knowledge, and you just build from there. Just do your thing, make beautiful or usable good fonts. So above the top loop of the figure 8 is what I call a user space. All the so-called complex scripts are for user space, all the complex scripts are encapsulated as just the same as simple scripts. Users should forget about the lower loop of the figure 8. And the lower loop of figure 8 is kind of an infrastructure space where the industry really needs to own its own encoding mess and provide solutions. We need to define systematic glyph names and reference glyph sets. So FYI, I think glyph names and glyph sets, they are really underestimated. They're kind of considered already resolved because they were created, those glyph sets like Adobe Latin 1, 2, 3, 4, 5, they were created mostly for simple scripts, and the mainstream practices so far of creating these glyph names and glyph sets are still tightly bound to encoded characters, Unicode characters. And so glyphs, they are not really treated as entities on their own merits. However, for complex scripts, their encoded characters are actually just overly abstract, and they naturally cannot adequately express the graphical structure of glyphs. And glyphs really, the they just cannot express the graphical structure of text. So glyphs really need to be analyzed and standardized on their own with their own well-defined identities. And glyph names then should be really designed systematically because they need to act as the human-friendly identifiers that are able to connect all the solutions the industry provide. Like our Indic Shaping for Type Designers project, this project I'm introducing now, is a major attempt of the industry solution to address this infrastructure space, this problem. We try to build glyphs names as strings being graphically descriptive and not under those abstractly encoded characters control to name them on their own. Glyph names, we believe they need to be both expressive enough in terms of graphical structures. You need to be able to describe the shape there in the writing system, in the script. And also they should be systematic enough to be somewhat interchangeable. But we're not doing another Unicode here, right? So we don't need to stick to a single system of glyph naming and glyph sets and glyph identities. So glyph names need to be publicly registered and namespaced, so we can still exchange. It's kind of like those legacy encoding solutions. We thought they were bad. They're indeed bad for text encoding, but graphical segmentation, this whole idea of abstraction layer, it's something intermediate. So we can actually benefit from not being so much unified. Diversity, right? So yeah, this is it. This is the technical background of the project Indic Text Shaping for Type Designers, and there is its GitHub repos URL. I hope it makes some sense to you. It's about how we should create a graphical segmentation layer of abstraction. And so we create this figure 8, we create the user space for users, for type designers, and we maintain, as the industry, we maintain the infrastructure space, and we try to provide the solid foundation for everyone not really willing to touch the complexity in the bottom. The actual content of the project is being developed in the GitHub repo and awaits community participation. It's gonna be a long-term, open-ended project. I hope it'll work. Thanks.